Hello students, today in our subject optics we are going to see the topics, and this is the episode number 4 and final episode of this lesson. We are going to see the parts of working of human eye, defects in human eye, myopia, hypermetropia, presbyopia, Astimatizm, then microscopes of simple, compound and the telescopes. It's a long lesson today, so kindly support me with your patience. Human eye. Students, human eyes are most valuable and sensitive organs responsible for vision. They are the gateway to the wonderful world. Structure of the eye. The eyeball is approximately spherical in shape with a diameter of about 2.3 cm. It consists of a tough membrane called sclera, which protects the internal parts of the eye. Now, important parts of human eye. First one, cornea. This is the thin and transparent layer on the front surface of the eyeball. It is the main refracting surface. That means it reflects the light or the image which it gains from the environment. When the light enters through the cornea, it refracts or bends the light onto the lenses. Then eye lens. It is the important part of human. I think this picture shows you more about. Here the light enters and this is the cornea and this is the iris. It reaches to the extreme and it is a retina, and these are the crystalline lenses we have. If you have any surgery in the lens, then you have to replace this lens only. Okay, eye surgery means they used to replace the lens. Then there is a optic nerve. If it fails, you are not able to see anything in future. Then this is the focal point of a lens. The next one, iris. Students, iris is a colored part. Okay, this is a colored part of the eye. It may be blue. This iris may be in blue color, brown color or green in color. Every person has a unique color, pattern and texture. Iris controls amount of light entering into the pupil like camera aperture. Pupil, it is the center part of the iris and it is the pathway for the light to retina. This is the pupil is the pathway of the light to retina. Then retina. I show you retina here. Retina, this is the back surface of the eye. It is the most sensitive part of human eye on which real and inverted image of object is formed. Then ciliary muscles. The ciliary muscles, eye lens is fixed between the ciliary muscles. Okay, the ciliary muscles. It helps to change the focal length of the eye lens according to the position of the object. Working of eye. Here in this picture you can see this flower move to the retina, pupil and everything, and finally at retina it have a inverted image. You can see it is a inverted image, right? This is the working of a normal eye. Now, the transparent layer cornea bends the light rays through the pupil located at the center part of the iris. The adjusted light passes through the eye lens. Already I told you eye lens is here. Eye lens is convex in nature. So the light rays from the object are converged and real and inverted image is formed on retina. Remember, light rays from the objects are converged and the real and the inverted image is formed here at this retina. Then retina passes the received real and inverted image to the brain through a optical nerves. Finally, the brain senses it as erect image. Power of accommodation. The ability of the eye lens to focus nearby as well as the distant object is called the power of accommodation of the eye. See, all our eyes have their own power of accommodation. This is achieved by changing the focal length of the eye lens with the help of ciliary muscles. Persistence of vision. What do you mean by this word? If time interval between two consecutive light pulses is less than 0.1 second, human eye cannot distinguish them separately and it is called persistence of vision. The far point and near point of the human eye. The minimum distance required to see the object distinctly without strain is called the least distance of distinct vision and it is called as near point of eye and it is 25 cm for normal human eye. Then far point of the eye, the maximum distance up to which the eye can see objects clearly is called as far point of the eye. It is infinity for Next one, defects in eye. A normal human eye can clearly see all the objects placed between 25 cm and infinity. But for some people, the eye loses its power of accommodation. This could happen due to many reasons including aging. Hence, their vision becomes defective. Let us discuss some of the common defects of human eye. This eyesight problem is most often caused by an eye that's too long, where the distance between the cornea and the retina is too great. First one, let's see myopia. What do you mean by this myopia and what are the defects we receive due to this myopia? Myopia is also known as short-sightedness, occurs due to the lengthening of eyeball. With this defect myopia, nearby objects can be seen clearly but distant objects cannot be seen clearly. The focal length of eye lens is reduced or the distance between the eye lens and the retina increases. Hence, the far point will be infinity for such eyes and the far point has come closer. Due to this, the image of distant objects are formed before the retina. This defect can be corrected using a concave lens. The focal length of the concave lens is computed as follows. Students, here you can see the myopic eye. Here in this myopic eye, this is the cornea and this is the pupil and this is a crystalline lens. If you receive any image and the eye without a problem will have normal, but a myopic eye which is stretched. Okay, see, a myopic eye, there is a difference between the myopic eye and the normal eye. This is the normal eye without eyesight problem, but this is a myopic eye, and this is the retina. Now, the focal length of the concave lens to be used is computed as follows. Let a person with myopic eye can see up to the distance x. If he wants to see all the objects up to infinity, then the focal length of the required concave lens is f is equal to minus x. And if the person can see up to a distance x and he wants to see up to the distance y, then the focal length of the required concave lens is f is equal to xy divided by x plus y. Hypermetropia. Hypermetropia, also known as long-sightedness, occurs due to the shortening of eyeball. With this defect, distant objects can be seen clearly, but nearby objects cannot be seen clearly. The focal length of eye lens is increased, or the distance between the eye lens and the retina decreases, or the defects occurred here. Hence, the near point will not be at 25 cm for such eyes, and the near point has moved further. Due to this, the image of nearby objects are found behind the retina. This defect can be corrected using a convex lens. This is the hyperopic eye. You can see the difference between that. If you have a hyperopic, then the vision went far from the eyeball. The focal length of the convex lens to be used is computed as follows. Let a person with hypermetropia eye can see object beyond a distance d. Suppose that we want to see all objects closer than this distance up to a distance d. Then the focal length of the required convex lens is f is equal to d capital D divided by d small d. Presbyopia. Next, eye defect. See, a presbyopic eye, it's a very long, and eye without that problem will be remain same. If you watch this, all the three pictures, you can see the small differences between the presbyopia, hypermetropia and myopia. Now, what do you mean by this presbyopia disease? Due to aging, ciliary muscles become weak and eye lenses become rigid. That means inflexible. You cannot have that muscles with the flexible structure. So, the eye loses its power of accommodation. Because of this, an aged person cannot see the nearby objects clearly. So, it is also called as old age hypermetropia. Some persons may have both the defects of vision, myopia as well as hypermetropia. This can be corrected by bifocal lenses, in which upper part consists of concave lens to correct myopia used for distant vision, and the lower part consists of convex lens to correct hypermetropia, which is used for reading purposes. Next one, astigmatism. and this is the eye with astigmatism problem. What is that disease? In this defect, eye cannot see parallel and horizontal lines clearly. It may be inherited or acquired. This is due to imperfect structure of eye lens because of the development of cataract on the lens, ulceration of cornea, injury to the refracting surfaces, etc. Astigmatism can be corrected by using cylindrical lenses, that means toroid lenses. Now, after this defects in eye, let's into the microscopes. There are two types of microscopes. One is simple microscopes and another one is compound microscope. Now, first of all, let's see what do you mean by this simple microscope. This is an optical instrument which helps to see tiny, very small objects, and it is classified as simple microscope. See, this is the view to use for a microscopic vision. There are basic microscope consist of an eyepiece and an objective connected by a focal tube. If a focus is available, it simply moves the object or the eyepiece up and down to lengthen the focal tube. Okay, it can use the eyepiece up to and down and lengthen the focal tube. Simple microscope may contain a reticle used to verify the size of objects. Now, the simple microscope has a convex lens of short focal length. It is held near the eye to get enlarged image of small objects. Let an object AB is placed at a point within the principal focus U, which is less than F, right? Here the object is placed AB within the principal focus. This is placed between the AB and which is the principal focus, and the observer's eye is placed just behind, which is the position. The convex lens produces an erect, virtual and enlarged image at A dash and B dash. Okay. The imaged form is in the same side of the object and the distance equal to the least distance of distinct vision D. For normal human eye, T is equal to 25 centimeter. See, the simple microscopes are low cost and ranging from normally if you see in dollars, $150 to $1,500, and it is easy to use. Image quality may not be the best. With one focal point, every scope usually has only one magnification range, and to magnify in a different range, a different eyepiece or objective must be used. The portable digital cameras with attachment lenses are also simple microscopes and handy for field use. Now let's see the uses of this simple microscopes. Simple microscopes are used by watch repairers and jewelers. These simple microscopes are used to read small letters clearly and to observe parts of flower, insects, etc. To observe fingerprints in the field of forensic science. Now let's move to the compound microscope. Compound microscope is used to see the tiny objects. It has better magnification power than the simple microscope. Magnification power of microscopes can be increased by decreasing the focal length of the lens used. And these compound microscopes are advanced microscopes containing multiple lenses. The first set of lenses, that means the objective, collects light from the sample. A separate set of visual lenses focus the light into the eye or camera. The light passes through one lens at a time, producing a two-dimensional image in this compound microscopes. Due to constructional limitations, the focal length of the lens can be decreased beyond certain limit. This problem can be solved by using two separate biconvex lenses. Now let's move to the construction of compound microscope. A compound microscope consists of two convex lenses. The lenses with the shorter focal length is placed near the object and it is called objective lens or objective piece. The lens with larger focal length and larger aperture placed near the observed eye is called eye lens or eye piece. Now, working of compound microscope. You can see here we use two lenses, okay, maybe of different shapes, and one is objective eyepiece and another one is near the eyepiece. The object AB is placed at a distance slightly greater than the focal length of objective lens. See, AB is placed slightly greater than the focal length of the objective lens U and F. The real inverted and magnified image A', B' is formed at the other side of the objective lens. Here A' and B'. The image behaves as the object for the eye lens. The position of the eye lens is adjusted in such a way that the image A', B' falls within the principal focus of the eye piece. Here you can see the image behaves as the object for the eye lens, and the position of the eye lens, right? The position of the eye lens is adjusted in such a way that the image A', B' falls within the principal focus of the eyepiece. Okay, this is the principal focus of the eyepiece. This eyepiece forms a virtual, enlarged and erect image A', B', and the same side of the object compound microscope has 50 to 20 times more magnification power than simple microscope. You can see a compound microscope here, and this is the eyepiece, okay, and this part is the eyepiece, and this is the body tube, and this is the objective turret, and this is the objectives here you can place. Then the and this is the objectives stage and the condenser lamp, and this is a slide with the specimen, and this is the fine focusing knob. You can use this knob to have a fine focusing, and this is the arm, and this is the coarse focusing knob, right? You can see how the vision is placed, or how the object is erected from the base, or the here you can have some lamp here, and the slide with the specimen. Okay, here you can have a specimen, sometimes blood or virus or bacteria, anything can be placed here. Then traveling microscope. A traveling microscope is one of the best instruments for measuring very small length with high degree of accuracy at the order of 0.01 millimeter. It works based on the principle of vernier. Its least count is 0.01 millimeter. Telescope. Telescope is an optical instrument to see the distant objects. Types of telescopes. There are two types of telescope. According to optical property, it is classified into two groups. One is refracting telescope, another one is reflecting telescope. In refracting telescopes, lenses are used. Galilean telescope, Keplerian telescope, achromatic refractors are some refracting telescopes. In reflecting telescope, parabolic mirrors are used. Gregorian, Newtonian, Cassegrain telescopes are some reflecting telescopes. And according to the things which are observed, astronomical telescope and terrestrial telescopes are the two major types of telescopes. Astronomical telescope. An astronomical telescope is used to view heavenly bodies like stars, planets, galaxies and satellites. Terrestrial telescope. The image in an astronomical telescope is inverted, so it is not suitable for viewing objects on the surface of the earth. Therefore, a terrestrial telescope is used. It provides an erect image. The major difference between the astronomical telescope and terrestrial telescope is erecting the final image with respect to the object. Advantages of telescopes. Elaborate view of galaxies, planets, stars and other heavenly bodies is possible here using with these telescopes. Camera can be attached for taking photograph for the celestial objects. Telescopes can be viewed even with the low intensity of light. What are the disadvantages? There are disadvantages for these telescopes also. What are they? Frequent maintenance needed for these telescopes, and it is not easily portable one. These are the Thank you students, thank you, and listen, up to this lesson we are going to write for the examinations. So remember and study well.